Let's continue with antiderivatives. So we're going to solve a different type of problem here. And this is also what's called differential equation. If you've heard of, sometimes some people refer to as DPQ. So differential equations. So this is the problem here. Find a function little f of x such that f prime of x is equal to 12x cubed minus 1. And also we know that, or it's given that f of 1 is 2. So this is a differential equation. What we have here is we want to find a function f of x, but we are given the derivative. Remember, you have the derivative, you want to find the original function. What do? You use antiderivative. So f of x actually is equal to the antiderivative of its derivative. So antiderivative of 12x cubed minus 1. So we find the antiderivative of this function. So I'm going to keep 12 the way it is. And x to the power of 3, when you take the antiderivative, is x to the power of 4 over 4. And then what's an antiderivative of 1? Antiderivative of 1 is x, because the derivative of x is 1. And of course, we don't forget the constant of integration. So f of x is equal to that. So f of x equals, now you cancel out 12 divided by 4, that's 3, x to the power of 4 minus x, and then plus c. Okay, so this is f of x. But if you look closely at the statement of the problem, they say f of 1 also has to be equal to 2. So we have f of x. What's f of 1? We plug 1 in for x. So f of 1, now f of 1 is equal to 3 times 1 to the power of 4 minus 1 plus c. But we know this is equal to 2. So this additional expression is just to help us solve for the constant c. So that gives us 3 minus 1 plus c equals 2, or 2 plus c equals 2. That means c equals 0. Now c equals 0, so the function f of x that they're looking for is equal to 3x to the power of 4 minus x, because c here is 0. So that's what we have. Remember, c is not always going to be 0. It depends on the problem you're working on. So for example, go over this problem here, and the problem I'm giving you is find f of x such that f prime of x is equal to 8x squared minus x, and f of 0 equals 3. So go ahead and find this. Now we're going to do another problem. go scroll up and erase. So the problem goes as follows. Same deal, differential equations. Find f of x such that f double prime is not f prime, f double prime of x is x squared, f prime of 0 is 8, and f of 0 is 4. Okay, now we want to find f prime. We want to find f of x, but f double prime is given. So how do we do that? Pay closely attention. Remember, we start with f of x. When you take the derivative, you get f prime of x. And then when you take the derivative, you get f double prime of x. So now we're going to go backwards because they've given us f double prime of x. We're going to take the antiderivative to get f prime. And then when we get that f prime, we take again the antiderivative to get f. So you get the picture? Let's go ahead and do it. First thing is, we take the antiderivative of f double prime to get f prime. So f prime of x is an antiderivative of f double prime, and f double prime here is x squared. That's what's given, and we know how to find the antiderivative of x squared is x cubed over 3, and then plus the constant of integration. So here I already have the shape of f prime. But look closely, they have given us a condition for f prime, and that condition is that f prime of 0 is 8. So we're going to use that to find this constant c. Let's go ahead and do that. F prime of 0 is 8. So, oops, I want to use the white color. F prime of 0 is 0 cubed over 3 plus c. But we know it's equal to 8 if you look up here. So this is equal to 8. Now you solve this for c, and you get that c equals 8. Now we know what c is. So if we know c is 8, then f prime of x is equal to x cubed over 3 plus 8. We just got f prime. However, if you look at the statement of the problem, we're looking to find f of x. So let's recap what we've done so far. We had f double prime. We computed the antiderivative to get f. So we're going to do the same thing now, the antiderivative of f prime to get f. So we're going to do it again. F of x is now the antiderivative of x prime, of f prime, I mean, x cubed over 3 plus 8 dx. And of course, I can rewrite this as x cubed over 3 is 1/3 times x cubed, and then plus 8 dx. And at this point here, I take the antiderivative. 1/3 remains 1/3 because it multiplies x to the power of 3. And then what's the antiderivative of x cubed is x to the power of 4 over 4. And then plus what's the antiderivative of 8 is 8x. And of course, I have a new constant of integration. This c has nothing to do with the c that we had before. It's a new constant of integration. So when we simplify, we get f of x is equal to 1/3 times x fourth to the power 4 is x to the power 4 divided by 12 plus 8x plus c. However, if you look at the statement of the problem up here, we're given that f of 0 is 4. F of 0 is 4, and we have f of x here. So let's go ahead and compute f of 0 using this expression. It's going to be 0 to the power 4 over 12 plus 8 times 0 plus c. But f of 0 is equal to 4. Remember what we have up here? So this f of 0 has to be equal to 4. And now you solve for the new c. What do you get for c? This obviously 0, 0. So you get that c equals 4. Now that c equals 4, I can write out the solution. So the solution here is f of x is equal to x to the 4th divided by 12 plus 8x plus, now I know c is 4, so this is the final answer. Now, to make sure that you guys understand the steps and what's involved here, I'm going to give you this problem. Find f of x such that f double prime of x is equal to 2x, f prime of 0 is equal to 6, and f of 0 is equal to, this is 0 here, is equal to 1. So go ahead and solve this problem. It's a differential equation problem.